11, sorry, Unit 11, Day 4 notes. Kind of more of the same stuff we were doing in Day 2, just kind of stepping it up a notch. So number 1 says, find the solution to the differential equation. You kind of have to memorize what those directions mean because I don't think it's very intuitive. When they say find the solution to the differential equation, they're giving us the derivative. We have to find the original function. So really that's just a fancy way of saying find y. All right, so we said how we're going to do it is separation of variables. So we cross multiply, you get x squared times dx equals y squared times dy. All right, and that gets all the x's on one side, all the y's on the other. All right, and then from there, we're ready to take the antiderivative of both sides. So we get x to the third over 3 plus c, and over here we get y to the third over 3. All right, so once you do that, again, you only need a c on one side, doesn't matter which one. All right, but the goal was to find y, so we need to get y by itself. All right, so from here, to get y by itself, probably my first move would be to multiply both sides by 3. Just remember, though, this left side, we're multiplying the entire thing by 3. On the right side, the 3's cancel. So on the left, we have to distribute the 3. If we distribute it to the term on the far left, the 3's cancel, and we're left with x to the third. Right, if we distribute it to the c, we're left with 3c, and we have y to the third. We said in the day 2 notes that anytime your constant gets more complicated than the letter c, all right, which happened here, our constant became 3c, that's when you should rename your constant. All right, and you have to keep track of what you rename it. So you have to go off to the side and kind of write a little note. All right, I usually start at the beginning of the alphabet. We're going to start with A. We're going to let A equal 3c. All right, so that means we have x to the third plus, instead of 3c, we're just going to substitute an a in, and it's equal to y to the third. All right, then we can keep going. We're trying to solve for y. We need to get the y by itself, so we should cubed root both sides. All right, and that really gets us y. I'm going to kind of switch sides. We're going to get y equals, we've got the cubed root of x to the third plus a. All right, and that's basically your answer right there. I'm going to star that. Basically the answer, but we have to find a. A is the constant. So that's when you go back up here to the problem. They gave us that point 0, 2. So we're going to plug in the point 0, 2 for x and y, and we can solve for a. So 2 equals the cubed root of 0 cubed plus a. 0 cubed is 0. So really you get 2 equals the cubed root of a. And if we want to get a by itself, we got to get rid of that cube root. So you could just cube both sides. 2 to the third is 8. So we get 8 equals a. So we basically had the answer. We just didn't know what a is. So we can copy it down. Y equals the cubed root of x cubed plus our a is 8. And that's our final answer. All right, let's look at the next one. All right, example 1, solve the differential equation. Again, all that means is we're given the derivative and we have to come up with the original function. I know this one doesn't look as typical as the other ones, but here we have this y prime in here. All right, y prime is the derivative of y. So we have to find the original. So we're going to find y. All right, to make it a little bit easier and look like some of the other ones we've done, let's rename y prime. All right, y prime is just the derivative of y. I would probably like to rename it as dy dx. All right, just another way to talk about the derivative, and that looks a little more like what we've been dealing with. All right, so this is basically the original problem. We have to find y. All right, so first step, separate the variables. Before we start thinking about cross multiplying, to make this look a little bit nicer, I'd say all this stuff is in the numerator. xy over here is in the numerator. We could write it over 1, and then it might be a little bit easier to cross multiply. If we cross multiply, we get xy times dx equals x squared plus 1 times dy. All right, and we need all x's on one side, all y's on the other. So we need to do a little bit of work here. So let's think. All right, we want our y to be with the dy, so I'm going to divide both sides by y. All right, and then we need this x squared plus 1 on the right side. We need that to be with our dx. So I'm going to divide both sides by x squared plus 1. So those cancel. So we're left with x over x squared plus 1 with a dx equals, I'm going to call this 1 over y dy. So at least now we have all the x's on one side, all the y's on the other. Our variables are separated. So at this point, we're ready to take the antiderivative of both sides. All right. Only thing is the left side looks kind of complicated. To me, that looks like something we'd probably have to do u substitution with, all right, to find your antiderivative. Think about what your u should be. Normally we use the numerator or the denominator. I'd be thinking if we use this denominator, it'll probably work. Think about if that's our u, the derivative of that is 2x. And in 2x, hopefully that x will cancel with the x on top. All right, so we're only going to do u substitution with the left side. The right side looks easy to take the antiderivative of. Antiderivative of 1 over y is just ln of the absolute value of y. So let's just work on u substitution. All right, for the left side of the equation, our u is x squared plus 1. If we take the derivative, du dx is 2x. All right, and we need to figure out what dx equals. So we can cross multiply 2x times dx equals du. All right, and to get dx by itself, divide both sides by 2x. And we now know what dx equals. So let's rewrite that left side. All right, our denominator was the u. Our dx is equal to du over 2x. The other side, I'm going to keep it the same. It's kind of like our side work over here. All right, and it looks like it's going to work out nicely that our x's will cancel. Those just disappear. We do have that 2 in the bottom, so I'd pull that out and call it 1/2 out in front. So we'd have 1/2 integral of 1 over u du. And over here we have integral of 1 over y dy. So at this point, we're ready to take the antiderivative of both sides. So on the left, we have 1/2 ln of the absolute value of u plus c. And on the right side, we have ln of the absolute value of y. Remember, you only need a plus c on one side. And just remember for u substitution, you always need to plug the u back in. All right, do not forget about that. All right, so our u was x squared plus 1. So really we have 1/2 ln of x squared plus 1 with a plus c equals ln of the absolute value of y. All right. So we're making progress, but we're not done yet. All right, remember what the end goal is. Our end goal, all right, was to find y, to get y by itself. So we need to first get rid of that ln. Remember how to get rid of an ln. You just put an e under both sides. The e and the ln cancel. So we're left with absolute value of y on the left. And on the right, we can split that up into kind of 2 separate terms that we're going to multiply together. So we'd be left with e to the 1/2 ln absolute value of x squared plus 1 times e to the c. And remember, that's a common error. A lot of kids want to put a plus sign in the middle. It's actually a multiplication symbol. All right, and before we move further, our constant just got more complicated than the letter c. All right, our constant was just a c. Now it's e to the c, so it's time to rename it just so this doesn't look super complicated. So write yourself a note on the side, start at the beginning of the alphabet, let a equal e to the c. We're just going to substitute an a in that spot. All right, and then the rest is going to stay the same. All right, we still have absolute values of y. Over here we have e to the 1/2 ln absolute value of x squared plus 1 times a. All right, so next up, keep the end goal in mind. The end goal is to solve for y. Right now we got to get rid of our absolute values. And we said the trick to getting rid of absolute values is just putting a plus or a minus on the other side. And that literally allows you to get rid of your absolute values right there. All right, so I'm just going to clean this up a bit. I'm going to kind of switch sides of the equation. All right, I'm going to put the y over here. We've got y equals plus or minus, all right, I'm going to put the plus or minus with the a times e to the 1/2 ln of absolute value of x squared plus 1. All right, so we got y by itself. Here, though, our constant did get a little bit more complicated than a letter. It was just the letter a. Now it became plus or minus a. So I would, again, rename it. Keep going down the alphabet. We already used a, so I'd use b. Let b equal plus or minus a. So we got y equals b times e raised to the 1/2 ln x squared plus 1 power. All right, so this is basically our answer right here, but we have to solve for b. All right, how we're going to do that is we have to plug in that point that we were given, 0, 6e. So we have to plug in our point, 0, 6e. 0 is going to be plugged in for x. 6e is going to be plugged in for y. I'm running out of room here, but I think we could still do this problem. I'll try to just switch colors so it's a little bit easier to see. All right, our y is 6e. We don't know b. We have e to the 1/2 ln of 0 squared plus 1. All right, so I think you guys know 0 squared is 0, plus 1 is 1. Absolute value of 1 is just 1. All right, so I might just kind of erase here since I'm running out of room and put that equals 1 right there. Next step, you guys know that ln of 1 really equals 0. ln of 1 is 0. So really what we've got here is 1/2 times 0, which 1/2 times 0 is just 0. All right, and I think we all know e to the 0, all right, is 1. So really all we have is b times 1, which is really just b. All right, so we get b is equal to 6e. All right, and then we can rewrite our answer one more time. This was basically the answer. We just didn't know what b was. We just found out that b is 6e. All right, and then we're multiplying that by e raised to the 1/2 ln absolute value of x squared plus 1. It's a plus sign in there. And that right there is our final answer. All right, let's keep going. We got example 2 next. They give us the derivative, dy dt. They give us a point, and it says which of the following is an expression for y of t. So we have to find the original function. So even though, it is multiple choice, we should probably still do the work. So start the same way, We can cross multiply to separate our variables. So if we do this cross multiply, we're going to get 4 times the quantity y plus 5 t to the third dt equals dy. All right, we got to get all of our variables on one side, t's on one side, y's on the other. So we could probably divide both sides by y plus 5. All right, so we're left with 4t to the third dt equals, over here I'm going to put a 1. Let's call it 1 over y plus 5 dy. Looks like t's are on one side, y's are on the other, so we're good on that. And we're ready to take the antiderivative of both sides. So if we do that, we get 4t to the fourth over 4 plus c. On the other side, you may be thinking we need to do u substitution here, and you definitely can. It will work out if you make the denominator your u. But think about, if you take the derivative of y plus 5, the derivative is 1. We said anytime your inside function has a derivative of 1, you really don't have to do u substitution. If you do it, you'll get the same answer. If you don't, that's okay. So you could really be thinking, what's the antiderivative of 1 over something? It's ln of the absolute value of y plus 5. All right, again, if you did use substitution, you would get the same answer here. All right, if we clean the left side up, the 4's definitely cancel. All right, and just from here, remember what the end goal is. The end goal is to find an expression for y, solve for y. All right, so we need to get our y by itself. So first thing, how to get rid of an ln, put an e under both sides. The e and the ln cancel. And over here, we can basically split this up into 2 separate terms that we're going to multiply together. Remember, it is multiplication, not addition. And over here, we have absolute value of y plus 5. All right, before we move on, our constant just got more complicated than a letter. The constant was c. It now became e to the c. So at this point, we should rename our constant, and you have to keep track off to the side. Let's start at the beginning of the alphabet. Let a equal e to the c. So we can rewrite this. I'm going to put the a in front. We got a times e raised to the t to the fourth power equals y plus 5. All right. So we're good. Now we need to keep thinking about what the end goal is to solve for y, to get y by itself. So we have to get rid of those absolute value signs. We said the way to get rid of those is you put a plus or minus on the other side, and that allows you to just drop your absolute value signs like that. All right, before we move on, our constant just got more complicated than a letter. Our constant was a. Now it's plus or minus a, so it's time to rename it. Let's call it b equals plus or minus a. So we could rename that with a b times e to the t to the fourth equals y plus 5. I think the last step, we're trying to get y by itself, just subtract 5 from both sides. So if we subtract 5 to the other side, all right, this is basically our answer. Our answer is basically y equals b times e to the t to the fourth power minus 5. All right, however, we have to figure out what b is, that constant. So go back to the beginning. That point they gave us was 0, 8. We have to plug that in. So plug in an 8 equals b e to the 0 to the fourth minus 5. 0 to the fourth is 0. E to the 0 is 1. So we really have 8 equals b times 1 minus 5. B times 1 is really just b. So to get b by itself, we can just add 5 to both sides. And if we do that, we end up with 13 equals b. All right, so we said this was basically our answer right here. We just didn't know what b equals. We just found that b was 13. So just put a 13 in its spot. All right, and let's see, this question was multiple choice. Is that an answer choice? 13e to the t to the fourth minus 5. It is. It's answer choice B. All right, let's keep moving. All right, we got another example. This is our last one. All right, this one looks hard, but we can handle it. Again, we're trying to solve for y. So separate your variables by cross multiplying. You get sine y times dy equals secant squared times dx. All right, and from there, it looks like all of our x's are on one side, all of our y's are on one side. So we could take the antiderivative of both sides. On the left, antiderivative of sine is negative cosine of y. On the other side, you have to think really hard. What's the antiderivative of secant squared? It was tan of x. And again, you need a plus c on at least one side. All right, so from here, we need to solve for y. We got to get the y by itself. Kind of hard since it's negative cosine y. So first, let's get rid of the negative. All right, we could divide both sides by a negative 1. On the right side, we could divide all of these terms by negative 1. So we end up with cosine y equals negative tan of x minus c. And at this point, you can rename the c. All right, c's our constant. You know, it did become a little bit more complicated, a negative c. Feel free to rename it if you want. You could call it plus a, but you don't have to. It's not super complicated, so I'd probably just leave it. All right, I'd be thinking, how can we solve for y? How do we get that y by itself since it's cosine y? All right, use some parentheses here. All right, we could rewrite this as the inverse cosine. Could write it as cosine with this little negative 1. I think you guys know with inverses, the input and the output just switch. Literally, those two parentheses just switch sides of the equal sign. We had the inverse cosine of negative tan of x minus c equals y. That's how you can get your y by itself. All right, so that's basically the answer. I'm going to write it a little bit nicer and kind of put the y over here. Y equals the inverse cosine of negative tan of x. Oops, not plus. It's minus c. All right, so this is basically our answer, except of course we have to find the C value. So go back and we have this point right here that we got to plug in, pi over 4 comma 2 pi over 3. So we're plugging in the point pi over 4 comma 2 pi over 3, all right, for our x and our y. So let's try that. We got 2 pi over 3 equals inverse cosine of negative tan of pi over 4 minus c. All right, we have to solve for c in this case. So let's just start simplifying anything we can. I think you guys know tan of pi over 4. The tan at pi over 4 is really just 1. So we've got 2 pi over 3 equals inverse cosine of negative 1 minus c. And from here, it kind of looks like we're stuck. You know, you can't do negative 1 minus c. Can't do much in this format. But what about instead of writing it as inverse cosine, what if we switch it back to cosine? You know, if it's the inverse, all right, these two parentheses would literally just switch spots. So if we change it to regular cosine, it'd be cosine of 2 pi over 3 equals negative 1 minus c. And I think that allows us to do a little bit of work. We still can't do the negative 1 minus c, but over here we should know cosine of 2 pi over 3. If you forgot, think about your unit circle. Pi over 3 in the first quadrant, that point is 1/2 root 3 over 2. So our cosine is our x value, 1/2. But we got to think, you know, is it positive or negative? 2 pi over 3 would be in this quadrant. Think about the saying, all students take calculus. All right, sine is positive in our second quadrant, but we're talking about a cosine, so cosine is negative. So it's going to be this 1/2, but it's going to be a negative 1/2. All right, and then we can add 1 to both sides. If we do that, we get negative c equals 1/2. And of course, we want c, so divide both sides by a negative, you get c equals negative 1/2. All right, so let's go back up to our answer. We said that this up here was basically our answer, so we can basically rewrite it. All right, if we rewrite this down here, we had y equals the inverse cosine of negative tan of x minus our c value was a negative 1/2. And of course, you could change that double negative to a positive if you wanted to clean it up a bit. But that would be that original function y that we were trying to find. All right, that's it for these day 4 notes. I hope they made sense. Give the day 4 homework a try.